All right. This is 2.5, part 3. I recommend you write this one down. This is probably the most difficult one in the lesson. It's more, it just takes time. So what we have is a 4th degree polynomial, and we want to find all 4 zeros. And they start off by giving us one of the zeros. And one of the zeros is a complex 0. We have to go out and find now the other 3. Give you some time to write that down. So that's what they give us in the box. And it wouldn't probably be a very good idea to use the possible rational zero test because you're going to have many, many possible rational zeros, because looking at factoring 60, you could do 60, you could do 30, you could do 20, 5, etc., etc. So we're going to start off by what they give us. They give us one of the zeros is 1 plus 3i. So that means it's a complex number. It also has to have 1 minus 3i. So what we're going to do is we're going to factor out both of those complex zeros. So then we'll be left with 2 more zeros to find. So we're going to use some long division here in a little bit, because synthetic division would also work. We do synthetic division once, we do synthetic division a second time, and then we're left with a quadratic. We're going to do it a little different. We're going to use long division and then factor the quadratic. So let's write out what we have as the 2 factors. So here are my 2 zeros. In factored form, what would it look like? In factored form, what would those 2 zeros look like in factored form? X minus 1 plus 3i, and then the other 0 x minus 1 minus 3i. So there's the 2 zeros in factored form. I have brackets just because I would have then double parentheses, which looks kind of messy. So what we're going to do is we're going to FOIL out these 2 brackets. And we'll be left with is a quadratic equation that will factor out from the original function. So here's where you have to be careful on. So we're going to FOIL. We'll take x times x as x squared. Then we're going to take x times negative 1 minus 3i. So I'm left with negative x, 1 minus 3i. Then I'm going to multiply here. I get negative x, 1 plus 3i. And then my last. Negative, negative turns that to a positive. And then I have 1 plus 3i times 1 minus 3i. Yes, ma'am.
Since they're conjugates, you want to do the first one.
And that's what we'll do in the black. Yep. Yep. Now let's distribute those x's through to the 2 parentheses. So my x squared stays as it is, and I'll distribute the red and the green x's. And some things are going to start to cancel out. So I have negative x, and then plus 3ix. That's from distributing here. And then I'll distribute again, negative x minus 3ix. Do you see anything cancel out now? Yep, the 3ix's will cancel. Now here's what you were talking about. You can use the shortcut because you're multiplying by conjugates in the black. So your middle terms will cancel out there. 1 times 1 is 1, is your first. And then your last is 3i, and negative 3i is negative 9i squared. Now I combine like terms with the red and the green. Negative 2x. And now what happens over here with the black? An I squared drops the I squared and changes the sign. So 1 plus 9, which is 10. So there is my quadratic function expanded out with those two imaginary zeros. So we're going to remove them from the function to get our last two zeros in that rest of the quadratic function. And here, that's why how synthetic division is also helpful, but also long division. So this is my original function. And then what's out in front is what I'm dividing from the zeros. That's right here, is in front. I'll give you some time to write that down. And then what we'll be left with is a quadratic equation that we can find our last two zeros. So now how long division works is I want to say how many times can x squared divide into x to the fourth. So if you need to write off to the side, do so. So I say x to the fourth divided by x squared. What am I left with? X squared. So now I go above its appropriate placeholder, the x squared placeholder. Now what do I do with that x squared? Remember what you do with it in long division? Multiply it to the three terms in front. So I take x squared times x squared is x to the fourth. X squared times negative 2x is negative 2x cubed. And then x squared times 10 is 10x squared. And here's where students forget, is you must change the signs of every single term because you are subtracting it. Minus, plus, minus. Be careful there. So now x to the fourth minus x to the fourth is 0. Negative 3x cubed plus 2x squared is negative 1x cubed. 6x squared minus 10x squared is negative 4x squared. And now I have to bring down the 2x. Because I have three terms in the front, I have to have three terms here when I multiply. So now I say, how many times can x squared divide into negative 1x cubed? So we'll just do it off to the side. Negative 1x cubed divided by x squared. What am I left with? Negative 1x or negative x. And now what do I do with that negative 1x? Multiply to the trinomial out in front. So negative 1x times x squared is negative 1x cubed. Negative 1x times negative 2x is positive 2x squared. Negative 1x times 10 is negative 10x. Be careful and change all the signs. Plus, minus, plus. So now 1x cubed and negative 1x cubed becomes 0. Negative 4x squared minus 2x squared, negative 6x squared, plus 2x plus 10x is plus 12x. And then I bring down that last term, negative 60. Now I say, how many times can x squared go into negative 6x squared? So negative 6x squared divided by x squared is negative 6. So that comes back up here, negative 6. And now I multiply negative 6 to the trinomial. Negative 6x squared plus 12x minus 60 change the signs, and when I'm done I get a remainder of 0, which tells me that this is factorable. So what I factored out the complex zeros, which were right here, x squared minus 2x plus 10, x squared minus 2x plus 10, and when I'm done, I'm left with x squared minus 1x minus 6. Now I have just this part left to find my last two zeros. So I try to factor that. In that case, I can factor that one quickly using the t-chart method or chart method. What are the factors of negative 6 that add to negative 1? Negative 3, positive 2. So then the zeros are 3 and negative 2. So the total of the 4 zeros are listed below. 3, negative 2, 1 minus 3i, 1 plus 3i. You could have done it a little differently. You could have used synthetic division here, then done synthetic division with the leftovers, and then you were left with a quadratic. It's just a different way to do it, using long division. That is our lesson for today. Here is your assignment. And then after lunch, we'll go over homework questions from 2-5.